It's not always a map for every situation. You have to try things and see what works. What I like to do is on the side of these kind of problems, I will write what are the possible identities I might use here. So the first identity that I might use is maybe I'll write, maybe at some point it will be helpful to know that secant is 1 over cosine. That might be helpful. I don't know for sure, but it might be. It might be helpful to know the Pythagorean identity that tan squared x plus 1 equals secant squared x. That might be helpful. Again, I don't know going in. I'm just writing what I think might help. So when I look at this problem, I say, okay, this one, and again, I don't know which is more beneficial. I know now only because I've done the problem. So maybe some of you would have started with this, with like rewriting all the secants with cosine. That's not wrong, it just might take a little longer. It's better to start with this one. And the way that I guessed this one when I started was I said, there are 2 terms up here. I'd really love to make this just 1 term. There's 2 terms here. I really want to make this just 1 term. So how can I do that? Well, if I minus 1 on both sides of this identity, identities are just like equations. They can always be added or subtracted, no problem. They can be multiplied or divided, no problem. As long as you do whatever you do to one side, you do the other side. So tan squared x equals secant squared of x minus 1. So please notice something here. This green box is the same as this green box. Which means if this green box equals tan squared, then this green box must also equal tan squared. So I'm going to replace this with tan squared of x. I haven't done a thing to the bottom yet. Haven't done a thing to the bottom. Now I want to simplify this so I can do what? Well, I can rewrite tangent and I can rewrite secant. So tangent is really just sine squared of x over cosine squared of x divided by secant, and secant is just 1 over cosine squared of x. So now I can do the algebra 1, keep change flip. So I'm going to keep the top. I'm going to change division to multiplication, and I'm going to flip this. I'm just going to finish off the algebra, and here's my final answer. Let me stop here and take questions before I go to the next problem. Yeah, that's what I was saying, right? Like, you don't really know. You just kind of have to try it. Here, I just kind of took a guess that this one would be better, because I could say that these 2 terms can be replaced with 1 term. It's always better to have 1 term over 1 term, because then you can keep change flip. Kind of, yeah. But you'll get, as you practice more, you'll begin to see the, the patterns. Questions? Edgar, Mariah, question? Okay. The first class where there have been no questions. That's good. So number 7. Number 7. So here we have 1 over sine squared A minus 1 over tan squared A. And again, I have no idea where to start, so I'm going to try some different things. Let me write down what my possibilities are. So maybe when I see 1 over sine, I'm thinking, well, maybe I need to use cosecant. That's one possibility. When I see 1 over tangent, I'm thinking maybe I need to use cotangent. When I see sine squared, I'm thinking maybe I need sine squared x plus cosine squared x equals 1. When I see tan squared, I'm thinking maybe I need tan squared x plus 1 equals secant squared of x. Yeah, or, right, right. Or, of course, I could use this. Tangent is equal to sine over cosine. Alright, so here's what we've got. So again, who knows which one to use? When I solved this problem this morning before school, I started with this one, number 4. That led to some really, really messy problems. I would have gotten the right answer eventually, but 4 led to some problems. Then when I was teaching it in the first 2 classes, I did number 5, and that was manageable. And then Janaea suggested to use number 1 and 2. That was the simplest way to do it. So let's follow what Janaea said. So Janaea said 1 over sine is really cosecant. So this is just cosecant squared of A. And she said 1 over tan squared is really just cotangent squared of A. And then she said, remember the other Pythagorean identity, which says what? Cotangent squared of x plus 1 equals cosecant squared of x. So Janaea said, well, if I know this is true, she said, why can't I just minus cotangent squared on both sides? And I'll get 1 equals cosecant squared of x minus cotangent squared of x. And she said, oh, what I've underlined in brown is the same as the brown box. So she said my answer is 1. That's it. Questions on this? These are puzzles. Some of you will try one thing, it won't work, and you'll give up, and you'll leave the problem away. Others of you will try one, it won't work, then you'll try something else, and then that still won't work, and then you'll give up. Others of you will try this one first, realize it doesn't work, try this one, see that doesn't work, and then see this and this and get it right. The people who will try 3 things are the ones who will develop the grit and will be successful down the line. Pre-cal is a metaphor for real life. Questions on number 7? Okay. And number 11. So number 11. Cosine squared of x times secant squared of x minus 1. So again, I'm going to list out what the possible identities I might use are. So I might say secant of x is 1 over cosine. That's a possibility. I might say I might use this. I might use this. Right? These are just some examples of what I might use. Again, no clear right way to do it. Or I might use distribute first and do nothing else, and then worry about these after. I don't know. That could be a strategy too. That's how I did it. Then Lucio told me a little bit quicker way he saw. That was a much better way. Lucio said, why don't we take and use number 3? So let's see what Lucio did. Lucio said, let's use number 3. It's okay. He said, I know that tan squared of x plus 1 is secant squared of x. So he said, why don't I just minus 1 on both sides? And then get tan squared of x equals secant squared of x minus 1. And he said, this yellow is the same as this yellow. So then he replaced this yellow with tangent squared. So he had cosine squared of x times tangent squared of x. He then went back to over here on the side and he said, well, I know tangent, right, this was his other identity he wrote down. He said, I know tangent equals sine over cosine. So then he said, let me use this over here. Times sine squared over cosine squared. And now finish up the algebra one. Finish up the algebra one. And there's your answer.